Hello everyone and welcome to PE Academy. So in this video I'm going to be taking you through what is Kirchhoff Voltage Law. So the Kirchhoff Voltage Law, also known as KVL. So if you are new to this channel, PE Academy, and you are yet to subscribe and you'd like to see content under engineering drawing and technical drawing, and also content under electrical engineering and electronics engineering, do make sure you consider subscribing. Alright, now let's come back to this video, Kirchhoff Voltage Law. So to start with, we are going to be stating what the law actually says. So according to Kirchhoff, the Kirchhoff Voltage Law states that, so it states that the algebraic sum of all voltages, of all the voltage around any closed loop, so around any closed loop in a circuit, is equal to 0. So this is what the law states. It says that what the algebraic sum of all voltages around any closed loop in a circuit is equal to 0. So before I continue, I've done a video that explains what a loop is, difference between a loop, mesh, elements, branches, junction, and every other thing. So that video, the link is in the description of this particular one in case you want to check that out. Now, for us to properly explain what Kirchhoff Voltage Law is, we will need to first of all draw a circuit. So let me just draw a very simple circuit. So right here we have our voltage source, and then we have another voltage source. So this is a very simple circuit. Here we have, this is a resistor, let's call this R1, and then this is our voltage source, let's call this is VS1, and then VS2, this is R2. So in this circuit now we have two voltage source and then two resistor, that is R1 and R2. So we want to use it to explain what Kirchhoff voltage law states. Remember, it says that what the algebraic sum of all the voltage around any closed loop in a circuit is equals to 0. Now, before we can start to simplify this, we have to first of all, when you have a circuit like this and you want to apply Kirchhoff voltage law, the first thing you have to do is to pick your direction of current. So let me write it here. So let me just note this. So the first thing I said you should do is what? So indicate what? Your current direction. So your current direction. Now you can decide to pick a clockwise or anti-clockwise direction, but personally I prefer to always make sure that my direction is always clockwise. So if you are choosing a clockwise, you are going to have something like this. So since that is the direction of current, and you can indicate that, okay, this is for current. So now once we've decided on the direction of the currents that we want to pick, now the next thing for us is to what? Is to put in the polarities of the elements in this circuit. All these are the resistor, the voltage source, they are referred to as elements. I've explained all of this in the video I did on the difference between elements, branches, loop, mesh, and every other thing. So for us to put in the polarities, so let me indicate it. So the next thing is to what? Is to note the polarities of the elements in the circuit. Now, in determining the polarity, the direction of the current is what we're going to determine what the polarity. Now, except for the voltage source, the polarity for the voltage source, that one is always is fixed. So the longer side is the positive, the shorter one is the negative. Same applies here. So let me just positive, and then this is negative. Now for other elements, like maybe if you have the resistor and then your capacitor inside, now the direction is what is usually influenced by, the polarity rather is influenced by the direction of the current. So if it is moving like this, so let me just have, this that we have here, let me just draw it out. So this is our R1. Now in this direction, that means we are having our current to be moving like this, which is, this is the direction of current. So when it is moving like this, our polarity will be like this, from positive to negative. I hope that is clear. Now let me also draw this here. So if we have this as our R1, and maybe for any reason, depending on the position we pick, our current direction is flowing like this. So let me indicate it as our current direction. Then that means the polarity is going to be plus here, and we are going to be having minus here. Whichever way it wants to come out, appear. If it is horizontal like this, even if it is vertical, if you have your elements on the vertical way like this, and then you have your currents moving in this direction like this, maybe clockwise, then once it is in this position, it will be coming down, then it is going to be what? From positive to negative. So if it is something like this, so if this is our R1, this is also R. So if the direction of the current is like this, direction of our current, so if it is moving like this, that's going to be positive and negative. I hope that's what I've just done here is clear. So that's what's going to help us in determining the polarities of those elements that we are having in this circuit. So with what I've explained, now let's add the polarity for R1. So that means we are going to be having plus and minus. In the same clockwise direction, it's going to be plus and minus. Now we've been able to put in their polarities. Now the next thing you have to do is to calculate the algebraic sum of the voltage around this circuit. Now for you to calculate it, you have to start from a particular node. So let's pick this node as an example. So we are going to go around it and calculate all of the voltage around this loop from here. So let me call this point A, B, C, and then D. Point A, B, C, and D. Now from A, B, and C. Now starting from A, by the time we add the algebraic sum, we are going to equate it to 0. Now doing this basically under Kirchhoff Voltage Law, it will help us in calculating the exact value of current that is flowing in this circuit. That's one of the concepts of voltage current, Kirchhoff Voltage Law. It will allow us to calculate the current that is flowing in this particular circuit. Now if you are to start from point A, and remember this is a series kind of connection, so that means definitely the current that is flowing through R1 is also the same current that is flowing through R2. I hope that is clear, in a series connection. So for us to calculate it, let's start from A, and then we move in a clockwise direction as we've indicated here, and then we move through points B, C, D, and back to A. Now before we start calculating, you also have to understand the difference between the concept voltage rise and then voltage drop. Now if you are moving towards the direction of current, if you are moving from positive to negative, so let me note it here. Okay, let me indicate it here. So if you are moving from positive to negative, so for example like this is positive to negative, so we consider that as a voltage rise. Sorry, if you are moving from positive to negative, you consider it as voltage drop, as voltage drop, and that will give us a value that is what? That is negative. I hope you can see it. All right, we consider that to be a negative value. Now if you are also moving from a negative to positive, we consider that as a voltage rise, and that will give us a positive value. Don't worry, you'll still understand what I mean with what I've written here. In case if it's not clear, just follow along. So I said from positive to negative, we consider that as a voltage drop. From positive to negative, consider it voltage drop, and that will be a negative. So from negative, let me use the red marker so that you can be able to identify them easily. So from negative, we are moving from negative to positive. We consider that as a voltage rise, and that will give us, it will be a positive value. So now with the idea of this, now let's go ahead and start to calculate the algebraic sum of voltage around this closed circuit. Now, I said from A, so by the time we get here, remember this is resistance R1 and this is current. So that means the voltage here is going to look at from positive to negative. That is going to be minus. Now remember that if you have to calculate voltage, the formula for V is equals to IR. We have V to also be V square over R. We also have V to be I square R to be I square R. These are the formulas that you can use to get voltage, but this is what we are going to be using most: current times the resistance. Now we've taken the current that is flowing in this circuit to be I, and then right here the resistance here is R1. So if we with that we can calculate the voltage here. So the voltage here is going to be I multiplied by what? By R. So that will be going to give us I multiplied by R. Now the R, remember the direction of the current is moving like this from positive to negative. So we are going to be having minus R1. I hope that is clear. So let's continue. Plus, now from positive to negative, the R2 here, from positive to negative, that is going to be giving us minus R2I now. By the time you get to this point, now if you look at this, this is already in voltage already. It's a voltage source, so there's no need to multiply our I with our V because we already have it in voltage. But look at it, it is from positive to negative, so that is going to be minus Vs2. That is our voltage source 2. If you should come back like this, and then there's nothing here, there's no element here. From point D to point A, we are going from negative to positive. That is going to be plus Vs from Vs2, and that is equals to 0. So look at Kirchhoff voltage. It was the algebraic sum of all voltages around a closed loop in a circuit is equals to 0. So we've been able to find the algebraic sum, and we've equated to 0. Now we can simplify this. We can simplify this further as having something like this. So here we can write this as minus R1I plus minus. Alright, so minus and plus here, definitely this plus will be out. So we are going to be having minus R2I and then minus Vs2 plus. So this is Vs1, voltage source 1 minus Vs1 is equals to 0. Now since we both have I is common here, so we can bring that out as having minus I, that is the current, into brackets R1 plus R2 minus Vs2 plus Vs1 is equals to 0. So now let's bring this to the other side of the equation, and that will be giving us Vs1 minus Vs2 is equals to I into brackets R1 plus R2. There's no big deal I've just done here. So let me just in case you are confused how I went from this to this, let me just simplify it here, just in case someone is watching this and is confused. So let me just do that here. So from here now, in case you don't understand why I arrived here. So what I'll just do is this. Now this V minus Vs2 plus Vs1 equals to, by the time we bring this value, we bring it to the other side of the equals to sign, we are going to be having I into brackets R1 plus R2. Exactly. So this I just change it around. That's what happened here. So if I should bring my Vs1 first and then followed by the Vs2 equals to I into brackets R1 plus R2. I hope you are seeing it. Alright, so you can see what you are having here is still the same thing here. So in case that is not clear, I hope that explained that. So now let's continue. So now with this that we are having here, we can use this now to calculate. Let me just create a box here. Now we can use what we are having here to calculate the current that is flowing here. And in doing that, we are going to have our I is equals to what? Vs1 minus voltage source 2 divided by R1 plus R2. That is if you are to calculate the current. Now you can see we've been able to get the current flowing in this circuit by applying Kirchhoff voltage law. Also, if you observe this thing very well, you see that with Kirchhoff voltage law, it's simply stating that what? All the voltage that is being supplied by the voltage source by V1 and V2, the algebraic sum of the voltage is also equal to what? To the voltage that is being used up in the circuit. And with that, now we can also see that Kirchhoff voltage law also goes with what? With conservation of energy. So where the energy generated is also equals to the energy being used up. So that is it on Kirchhoff voltage law. In the next video, I'm going to be looking at real-time example. So in case if it's not still clear, if you watch that example, we are going to be using real values. But one thing I want you to understand in these steps is that you understand what Kirchhoff voltage law is at what. It said that the algebraic sum of all voltages around any closed loop in a circuit is equals to 1 to 0. And I've showed you how to go around when you are dealing with Kirchhoff voltage law. Once you have your circuit, you pick your current. I've noted here, indicate your current direction. This time around is the clockwise direction. Then you note your polarities. I've talked about how to get your polarities. For the voltage source, the polarities are always constant, they're always fixed. The longer side is positive, the shorter one is negative. Same thing applies here. Now for the other elements, it is the direction of the current that will determine the polarities of the elements. For example, in a clockwise, it goes from positive to negative, So when that is done, you start to calculate the voltage across each of those elements. Once you add them up together, you equate them to 0, and then you'll be able to go ahead with your calculation. So if you find value in this video, please give it a thumbs up. And like I said, in the next part of this video, you are going to be looking at real-time example under Kirchhoff voltage law. So thank you very much, and I'll see you all in the next part of this video.